What we're going to do now is actually look at the code behind the game that you saw run a little bit earlier. And let's start with a visual glance at the way I have Visual Studio set up. Of course, over here in the Solution Explorer, you can see that we really don't have too much in the way of modules being used here. We have the class card deck that we talked about before. We have the in-between rules class that we talked about. And right now on the screen in the source window, I have the form main source code. Now, remember that you can use the #region preprocessor directive to screen out. Well, it's not really a preprocessor directive, but it's an editing directive that allows you to hide and expose lines of the program. And just by coincidence, I happen to set them to the 5 programming steps. So I have an initialization, input, process, display, and termination. And really, the user interface for almost any program usually follows those 5 steps pretty closely. So it makes a convenient way for you to think about writing the user interface. If we look at the design, that should look familiar to you. What you didn't see before is over here, there's a text box. That's where we show that pip when they have a card that's too low. There's one in the middle here. That's the one that shows when they're in between the two, and then there's one over here that's hidden for displaying when the card is above. And then the message goes in the middle here. The message is actually centered on this group box, not the buttons. All right, so let's take a look at the code. Let's go with initialization code first. I'll make this a little wider so we can see a little more. We already know that this is going to be the constructor because it shares the name with the class itself, form main. And as you can see, we're going to inherit from the Windows Forms class so that we get all the functionality of a Windows form. Some variables that we're going to be using in here. Again, I use symbolic constants. I define them as constants. These are like the old pound defines in C or C++. And I use those just to simply make the code a little more readable. All of the objects that we've dragged onto this surface are listed here. And then we have the initialize component. This is the Windows code. This method right here is actually populated by Windows itself. So these are all of the things that are done in the background in terms of building how Windows builds up those objects and places them on the screen. That's written for you in the background process by Windows, so we're not going to do much with that. Once we've done that, I set up the balance in the text box to be whatever initial amount that I wish to use. I've got that coded as a property. You'll see that in a minute. The rules, I have a wager, and I've converted it to a string, and I've put it in the wager box. And I make sure that I'm going to check to make sure that those are actually integer variables before they go in. That's probably not needed. And then I go and I shuffle the deck, and we're done with the initialization code. There's nothing special that's done here. Pretty standard stuff. There are no special resources called. There's no connections, database connections, printer connections, network connections, or any other resource that is not automatically closed down when the program ends. So because of that, the termination step is very, very simple. Once I've initialized things, then I go to my main method, which is a starting point for all of the Windows programs that are written in C#. I create a main object, and then I run the application, and we're off and running. Once I do that, then we see this visual representation of what the game is supposed to look like. Now, while we're here, let me pull this back again. And see if I can make this a little bigger. My preference is to have these things in alphabetical order rather than to have them grouped by functionality. It makes it easier to find, or at least I think it does. So we talked about using the dot operator before, and we had a specific section on it. All of the things that you see in this window over here become properties that you have access to yourself. So if I have something called button bet, I can do button bet dot any of these things and change them in program code just as though I'm changing them here in design mode. So all of these things are changeable at runtime by simply using the dot operator. The reason that we use this simpler version is because it allows us to see instantly what our changes look like without rerunning the program. But the dot operator is used to form the link between the object that you see that has the sizing box around it, or the focus box, and the properties that you can play with over in the properties window. Now, we've got the program running, so let's take a look at the input step. The input step has a variety of different methods associated with it. Some of them are just overhead stuff. For example, clear ranges. When I want to start off with a fresh looking system, I can clear these boxes here and here. I can even clear the text boxes, and I want to clear anything that's been displayed in terms of low, middle, or high. So the purpose of this method over here then is just to clean those out so that nothing is being displayed. So clear ranges is done usually before a fresh bet or after a bet's been made and we want to reset things. The reset button, which we really didn't use, if you click on that, the purpose of that is to reset the balance to the initial amount of $100 and to set the default wager to $10. And that's exactly what you can see that we do. And then we call clear ranges to make sure that we're not showing anything down in the lower parts as far as card pips. Then we have the two buttons. The first one, the deal button, is the one that is going to be responsible for displaying the cards that the person, the player, has to look at to decide whether they wish to make a bet or not. So one of the first things that we do is we clear out any old information that was then. We clear out the label, the outcome text. That's the one that says we won or we lost. And then we go and we call the rules class to see, do they have enough money left to continue playing the game? If the return value is 0, that means they're broke, the game's over, and we return. And the reason that we don't just end the program at that point, which we could, but that's not a very graceful way of getting out of here. That would just be all of a sudden you run out of money, you didn't know that, you click the bet to play the next one, and all of a sudden the game ends. So rather than do that kind of behavior, we return and we allow them to close the game themselves, or they can press the reset button, which gives them a fresh set of money to play with. So assuming that they do have a balance, then we call get cards left. The reason that we wanted to do that is because we want to make sure that there's at least 3 cards left that can be dealt. And if they're not, if the number of cards left is less than 3, we don't have enough to play the next hand. So what we do is we tell them we're going to shuffle the deck, or the deck was shuffled, and then we call my rules shuffle. And the shuffle routine then, as you might guess, is going to call the card deck shuffle routine, and the cards get shuffled. Assuming that we didn't have to shuffle the deck, then all we have to do is actually deal out the cards. So we call it with cards, and if you look up here, cards holds the 3 cards that were dealt to us to play the game. And we get the bet result and we get the position. This position variable over here is what determines where that card is displayed, whether it's displayed to the left of the low card, in the middle, or to the right. So we have a position indicator up here, tie, player wins, dealer wins. And then we have a method that we called show high-low, and we'll see that in just a second. So once we've called that click event, that button deal click event, we pretty much have all of the input data that we need to be able to play this particular game. So the next step is the process step. You can keep hitting that deal button. Every time you hit this button over here, a new set of cards appears down in these two windows. So we're just kind of rolling through the deck. That improvement that was suggested, of course, after I wrote the code, would be to have each time you click the deal button, maybe you lose $1 in your balance. That's probably a good idea, because you could just spin here until you got ace-king every time and continue to double up ad infinitum. By having an ante required to hit the deal button, that might be a good idea. Unfortunately, I didn't think of that. That's why you do a design walkthrough. If this guy had been at that design meeting, which he wasn't there for, not my fault, we could have thought of that and maybe implemented it. So that will be in release 2. All right. Now what we do is we want to make sure that whatever they typed into the wager window, because they can change that from the default 10 to whatever they want it to be, but it is not supposed to be higher than what they have. So we have a bet covered here. In other words, if you have a $100 balance, you can't bet $150. So what we want to do is to check to make sure that we have the bet covered with the balance that's in the betting pool. So if that particular method returns a 0, that means that we've tried to make a bet that's larger than the amount of money that we have. And we then set the focus back to that text box, and we return and we ask them to do it again. Now, the bet result, let's see, where did we do? Oh, bet result was set in the input part. This is a variable that is a global up here. So we know what the result of this outcome is. If it's a tie, we say dealer wins, because dealer wins ties, and then we just do a minus equal on their balance for the amount of the wager. If the player wins, we display the message and tell them that, and we add the amount that they bet to their betting pool. And then if the dealer wins, in other words, it's not a tie, but it's lower or higher than the range of cards, then we do the same thing as the tie, the house wins. Then the text balance is updated to bring up the balance. And now this is where that position variable comes in. This is what displays where the cards appear, or where the card that was dealt appears. And we have case 1 is where it is less than the lowest number. Case 2 is, let's see, case 2, case 2 would be where it's a tie. Case 3 is in the middle. Case 4 is a high tie, and case 5 is more than that. So these positions tells where the card that is dealt, card number 2, remember there are 3 cards, the low card, the high card, and the card that represents the one that's the last card dealt. This tells where in those text boxes this thing is actually displayed. There's actually 5 text boxes here. So this would be used if it's too low. This would be a low tie. This would be a winner. This would be a high tie. And this would be too high. Okay? So that's what those 5 positions are. Once we've done that, we're done displaying the results. We've updated the wager boxes. We've displayed the message that says you've won or you're lost. And we've also positioned the card pip in the region that makes sense with the game that was just played. The termination step, very difficult. We close it, and it's up to the Windows Memory Manager to clean up after us. We don't have to do anything, so we're all done. That then describes all the steps that we have to do with respect to playing this game from the user interface point.